You are welcome to this class, students. How is your day going? Now, in this class today, we are going to be taking stoichiometry, continuing on it. Before I forget, my name is Dr. Kingsley. Welcome to Des Brain Academy. Now, in this class, I will be taking us on molar mass, and Avogadro's number. How do we get the molar mass of compounds? How do we get the molar mass of molecules? How do we get the molar mass of atoms? Now, what is molar mass to start with? Molar mass of a substance is the mass of 1 mole of its entities. The mass of 1 mole of its entities. Remember, an entity that we are talking about here might be atom, it might be ion, it might be molecule. So the mass of 1 mole of the entity, okay, of that substance is what we call the molar mass of that substance. How do we get it? We can calculate the molar mass, okay, of a substance from the atomic mass that is provided in the periodic table. The atomic mass that is provided from the periodic table. We can use it to get the molar mass of what? A substance. Now, let's say, for example, the molar mass of carbon. The molar mass of carbon is equal to the atomic mass of carbon. Why? Because carbon exists, okay, as an atom. So, molar mass of a substance that exists as an atom is equal to the atomic mass of the substance. So when a substance exists as an atom, the molar mass of that substance will be called the atomic mass. Now, example here, carbon exists as an atom. The molar mass of carbon is approximately 12 gram, okay, per mole. The unit of molar mass is gram per mole. That is the unit. Now, what is the molar mass of sodium? The molar mass of sodium, okay, is 23 gram per mole. Okay. What is the molar mass of lithium? Okay, remember lithium exists as an atom. Or let me take, okay, calcium. The molar mass of calcium bigger than lithium. The molar mass of calcium is 40 gram per mole. Now, all these elements I gave you here, or all these substances I gave you here, they exist as an atom. Remember, molecule differs from an atom because combination of atoms will give us a molecule. For example, oxygen is written as O2, which is what? An atom of oxygen plus another atom of oxygen. That is 2 atoms. So since it's made up of 2 atoms, oxygen does not exist as an atom, it exists as a molecule. So, but sodium, for example, you cannot write sodium as Na2. If you write this way, you are telling us it's a molecule, but it does not exist as a molecule. It exists as an atom, that is Na. So, the molar mass of any substance that exists as an atom is called the atomic mass. So, the atomic mass of carbon is the same thing as the molar mass of carbon. The atomic mass of calcium is the same thing as the molar mass of calcium, because calcium exists as a molecule. What of if the substance exists, because calcium exists as an atom, what of if the substance exists as a molecule? What will be the molar mass? Because we are looking at molar mass. Now, I want to give you another point that you should know that what? You should know that the molar mass of a substance, okay, that exists as a molecule will be equal to the molecular mass, okay, of that substance will be equals to the molecular mass of that substance. So some substances exist as what? As a molecule. So if a substance exists as a molecule, the molecular mass the molar mass will not be the atomic mass. It will be the molecular mass. Let me give you an example. If you take oxygen, for example, okay, oxygen exists as a molecule. But we know that what? One atom of oxygen is equals to 16 grams. One atom. But this 16 gram, will it be the molar mass of chlorine? No. This is the atomic, will it be the molar mass of oxygen? The answer is no. Because 16 gram is the atomic mass of oxygen. That is the mass of one atom. Now, but oxygen exists as what? O2, which is what? A molecule. So the molar mass of oxygen is not the atomic mass. The molar mass of oxygen will be the molecular mass. And what is the molecular? So it will be 16 times 2. 16 times 2, which is what? 32 gram per mole. So the molar mass of oxygen is 32 gram per mole, which is the molecular mass. It's made up of what? 2 atoms. That is a molecule. Mass of one atom, which is 16, times the number of atoms, which is 32. So never you say that the mass of, the molar mass of oxygen is 16. But the molar mass of oxygen is what? Is 32 gram per mole, which is the mass of the molecule. Now, what are some atoms that exist as a molecule? We have seen one, which is oxygen, O2. The molar mass will be 16, mass of one atom times what? 2, which is 32 gram per mole, right? What is the molar mass of nitrogen? The mass of one atom of nitrogen, only one atom, is what? Is 14. So the molar mass will not be 14, which is the atomic mass, one atom. The molar mass will be 14, which is one atom, times the number of what? Atoms that makes the molecule, which is times 2. So that is 28 gram per mole. So what is the molar mass of chlorine? The molar mass of chlorine is not 35.5. No. 35.5 is the mass of only one atom of chlorine. And the atomic mass of chlorine, which is 35.5, is not the molar mass. The molar mass of chlorine will be the molecular mass, not the atomic mass. Molecular mass is a molecule making up of 2 atoms. So it will be 35.5 times 2, which is 71 gram per mole. So most times when you ask students, what is the molar mass of chlorine? They will tell you 35.5. But now you've known that the molar mass of chlorine is not 35.5, but 71 gram per mole. 35.5 is the atomic mass, not the molar mass. Okay? Why is the atomic mass of chlorine not the molar mass? Because chlorine does not exist as an atom. It exists as a molecule. It is only a substance that exists as an atom that the atomic mass is qualified to become the molar mass. Now, what is the molar mass of ozone? The molar mass of ozone will be 16 times 3, which is what? 48 gram per mole. Okay, and so on and so forth. So we have known how to get the molar mass of molecules. Now, how do we get the molar mass of compounds? Now, we can do that, getting the molar mass of compounds. The molar mass of compounds will be the summation of the molar mass of the atoms that makes up that compound. The molar mass of a compound will be the summation of the molar mass of atoms that makes up what? The compound. All right. So now, if you look at this now, you will see that what? When we write CaCO3, CaCO3 is made up of calcium atom, carbon atom, and oxygen atom. We sum all the molar mass of these atoms to give us the molar mass of the compound itself. So what does it mean now? What it simply means is that what? The molar mass of what? Of calcium triosocarbonate 4 will be equal to the molar mass of calcium, which is what? 40, plus the molar mass of carbon, which is what? 12, plus the molar mass of what? O3. O3 is what? 16 multiplied by 3, because oxygen is 16 multiplied by 3. That will give us what? 40 plus 12 plus 48. And that will give us what? 100. The unit, okay, is a gram per mole. All right. So what will be the molar mass of Na2CO3 0.10H2O? What will be the molar mass? The molar mass will be the summation of what? Of the atomic masses. Or the molar mass will be the summation of the molar mass of each atoms that makes up the what? The molecule. Now, how do we get this? This will be equals to the atomic mass of sodium is 23 multiplied by the number of atoms, which is 2, okay, plus the molar mass of carbon, which is what? 12. Remember, the molar mass of carbon is also the atomic mass of carbon, because carbon exists as an atom. Then plus the atomic mass of oxygen is what? Is 16. Then multiplied by the number of atoms of oxygen here, which is equals to what? 3. So when we do this, we add plus, okay? You have here 10 here, okay? Brackets, water, 10 H2O. So 10, we multiply all this H2O. And H2O means 1 times 2 for hydrogen, because atomic mass of hydrogen is 1 times the number of atoms, which is 2. Then plus oxygen, 1 oxygen, which is what? 16. Okay? So when we multiply this out, we will be having what? 46 plus 12 plus 48. Okay? Plus 18. I mean 10 times 18. 10, if you, 1 times 2 is 2 plus 16. That is what? 18. So when we do this, this plus this will give us 106 plus 180. Okay? 106 plus 180. Okay? We have 106, 180. That is 682. So that is what? 286. Okay? Gram per mole. That would be the answer for the molar mass of what? Of sodium triosocarbonate 4 decahydrate. 10 is decahydrate. Now, sometimes examiners might want to test students on a tricky question. They might say, if the molar mass of Na2, okay, CO3 .xH2O, okay, is 322, comma, find the value of x. We are looking for the value of x. So let us look at the value of, find the value of x. Now in this case, now we are given what? The molar mass to be 322. Okay? We are looking for the value of this what? X. Now as a solution now, it will be easier for us to what? Easy for us to what? To find. How do we do this? Molar mass of Na2CO3 .xH2O is equals to what? 322. What it simply means that Na2, let me come back here, Na2CO3 .xH2O is equals to 322. Now, if we sum all the atoms we have here, that will give us the molar mass, which is equals to 322. So what it simply means is we'll be having sodium, which is 23 multiplied by 2, right? plus carbon, which is what? 12, right? Plus oxygen, which is what? 16 times 3, right? Then plus X multiplied by what we have here is 1 times 2 for hydrogen plus 16 for oxygen. Everything will give us 322. Now, if we sum this thing up, we'll be having what? 106. So 106 plus X times what we have here is 18. 1 times 2, 2 plus 16. That is what? 18. 18 times x will give us 18x. Everything will give us 322. 106 plus 18x is 322. So we collect like terms. 106 goes to this side. We have 18x is equals to 322 minus 106. So 322 106. Okay, 12 6 1 2. That will give us what? 18x is equals to 216. So what is x? X will be equals to 216 divided by 18. So x is equals to 12. So we have gotten x to be 12. So that compound they gave us, which is Na2CO3.X H2O, is actually Na2CO3.12 H2O. So that is the answer. So as we continue this class, subscribe to my channel, like and share my videos.